You know what's very exciting about this video? This is the first new material that you will learn in Algebra 2. Congratulations to making it to the new material. Today, we're going to talk about inequalities. So usually when we do algebra, we have an equal sign and we're trying to, we manipulate both sides of the equations and we get a solution for x, where x equals something. But here, x is not going to be equal to something. We're going to have it unequal. For instance, we have x plus 8 is greater than 2. So we're going to get a solution and a graph for this. Okay, so the first thing we're going to do is we're just going to solve it like we normally would in the algebraic equation, where that greater than sign is just sort of where the equal sign would be. So I subtract 8 from both sides and I get x is greater than negative 6. Okay, so if I'm going to graph this, I'm going to write negative 6. That's going to be my point of interest, okay? So anytime you have a solution like that, that'll be the sort of point that you graph, and you really don't need to graph any other points. Now, since x is greater than negative 6, I'm going to show that x kind of reaches where that gold line is. Yeah, so all of those numbers along there are going to work, right? 0 is greater than negative 6, 5, and any number greater than those. So let's go ahead and take a look at these symbols and representations. So anytime you see greater than or less than, okay, you're going to be seeing an open dot. Okay, this is very important. If it's just greater than, then that means, the solution does not actually include that number. So you show the open dot to show that actually here, there's a hole in my graph. I don't actually include that number, but I do include all the numbers greater than it. Okay, and then we have greater than or equal to, and there is where we're actually going to fill in their dot because I'm showing that I actually include the number that follows, right? If it's x is greater than or equal to negative 6 is included in my solution. And then similarly, right, we'll just show the lessons in the same manner, but just with the arrows pointing to the left. Let's look at an example of this. So if we multiply or divide by a negative number, okay, this is another important point that we're going to run into. This is going to flip the inequality. So if it's greater than, it'll become less than. If it's less than, it'll become greater than. The equal signs will stay whether they're there or not. Let's look at an example here. So I'm going to add 6 to both sides here from this equation, just like we normally would in algebra. And then I have negative 2a is less than or equal to 10. So I'm going to divide by negative 2. Okay, but what happens is I get, a and negative 5 on the other side, but the inequality was less than or equal to, so I'm going to switch that inequality to be the other way around. It's going to be x is greater than or equal to negative 5. Okay, so negative 5 is included in my solution, so it's a closed dot, and then it's greater than, so it's going to be an arrow going to the right. Okay, next one. So let's say I take another example, and I'm going to be looking at true or false inequalities. So for instance, you know that 5 is not greater than 10, right? So if I said 5 was greater than 10, you would say that's false. So we're going to solve this equation by distributing that 6. We'll get 6x plus 12, and then on the other side, we'll combine those like terms. So we get 6s minus 8, and then when we solve, we get 12 is less than negative 8. Is this true? Well, no, this is not true. We know this isn't true, so it's a false inequality. We'll take a look at another example of this true-false thing. Say we have 4 times 2a plus 1 is less than 12 times a plus 6 minus 4a. So we're going to start by distributing that 4, distributing the 12. So we get 8a plus 4 is less than 12a plus 72 minus 4a. Then we have a couple of like terms, so we will combine those on one side. But then I look and I see that I have 8a on both sides, which means I can let them go poof. They go away. And then I get 4 is less than 72, which is true. Woohoo! Okay, so that was a true inequality. Let's take a look at a different example, just of regular inequality. So we're going to subtract 16 from this equation. So we get negative 2a is less than negative 12. So then I get a is less than 6. Oh, no, no, no. We have to flip the inequality because we've divided by a negative. So we get a is greater than 6. Okay, so the way we represent that is we do an open dot at 6 going to the right. So let me show you why this is what happens. So if I have negative 2a is less than 12, and I add 2a to both sides and add 12 to both sides, I'll get 12 is less than 2a, divide by 2, I get 6 is less than a, which is the same thing as saying a is greater than 6. And that is why you flip the inequality. Okay, so good luck on your homework. Let me know if you have questions, and I hope you have a great day.